Welcome to Astronomy Daily. Give us 10 minutes and we'll give you the universe. I'm your host, Anna.
And I'm Avery. It's great to be with you. We have a fascinating lineup of stories today, covering everything from the outer edges of our solar system to the challenges we face right here in Earth orbit.
That's right. We'll be discussing a new structure found in the Kuiper Belt, a landmark year for Rocket Lab, and the end of an era for a legendary NASA mission. Plus, a surprising discovery from the James Webb Space Telescope about a so-called super-Earth.
And we'll even touch on the unique business of deep space memorial flights. But first, let's talk about a problem that's only getting bigger. What to do with satellites when they die.
Exactly, Avery. With mega constellations like Starlink launching thousands of satellites, the question of their disposal is critical. There's a big debate between two main philosophies, design for demise, or D4D, and design for non-demise, D4ND.
Right, so D4D means the satellite's designed to completely burn up in the atmosphere upon re-entry. Sounds like a clean solution, right? Just cosmic dust.
That's the idea, but it's not that simple. Environmental scientists are raising concerns. When these satellites, which are largely made of aluminum alloys, burn up, they release tiny particles of alumina. Alumina, okay. These particles can act as seeds for chemical reactions in the upper atmosphere, potentially damaging the ozone layer. Also, the intense heat of re-entry can break apart atmospheric nitrogen, creating nitrogen oxides, which are powerful greenhouse gases.
So even burning them up has an environmental cost. What's the alternative then? Designed for non-demise?
Exactly. D4ND means building satellites to survive re-entry, allowing them to be guided to a safe splashdown in a remote ocean area, like the spacecraft graveyard in the South Pacific.
That avoids the atmospheric pollution, but it comes with its own risk. What if something goes wrong? You could have a washing machine-sized piece of metal hitting the ground instead of the ocean. It's a tricky balance between atmospheric risk and ground impact risk.
It really is. There's no perfect answer yet, but it's a conversation the space industry has to have, and fast.
All right, let's move from Earth's orbit way out to the edge of the solar system. Astronomers at Princeton University have found something new in the Kuiper Belt.
The Kuiper Belt, for our listeners, is that vast ring of icy bodies beyond the orbit of Neptune, with Pluto being its most famous resident. So what did they find?
They found what they're calling an inner kernel of objects. For years, we've thought of the Kuiper Belt as having two main populations, a cold classical group with stable circular orbits, and the hot group with more erratic tilted orbits. But by using a data mining technique on a catalog of over 600 Kuiper Belt objects, they identified this third group, the kernel, which has very flat, tightly packed orbits, distinct from the others.
That's fascinating. A whole new structure hiding in plain sight. What does this mean for our understanding of the solar system's history?
Well, the leading theory is that these objects formed even closer to the sun and were pushed outward during Neptune's Great Migration early in the solar system's history. The existence of this tightly packed kernel could provide new constraints for models of how that migration happened, giving us a clearer picture of our cosmic backyard's formation.
And of course, any new structural information about the Kuiper Belt reignites the hunt for the hypothetical Planet Nine. The unusual orbits of some of these distant objects are what led to the theory of a massive undiscovered planet in the first place.
And that's the ultimate mystery out there, isn't it? While this kernel doesn't directly prove its existence, it adds another layer of complexity to the outer solar system's dynamics. Every new discovery like this helps astronomers refine their search, telling them where to look and, just as importantly, where not to.
From the far reaches to the commercial space race closer to home, Rocket Lab has just capped off an incredible year.
Incredible is the word for it. In 2025, they flew their Electron rocket 21 times with 0 failures. That's a remarkable achievement for any launch provider and really solidifies Electron as a reliable workhorse for small satellites.
It certainly is, but they aren't just resting on their laurels. They're making huge strides with their next generation rocket, Neutron. This is their larger, fully reusable rocket designed to compete with the likes of SpaceX's Falcon 9.
And it has that amazing fairing design they call the Hungry Hippo.
Yes, instead of the fairings separating and falling away, it opens up like a giant mouth to release the satellite and then closes before the rocket returns for landing. It's an innovative way to simplify reuse.
As if that wasn't enough, they also secured a massive $500 million contract from the Space Development Agency to build and operate 18 missile warning and tracking satellites. Rocket Lab is quickly becoming a major end-to-end space company, not just a launch provider.
Speaking of major players, we have to mark the end of an era. After 26 years of service, NASA's Terra satellite has been officially retired.
Wow, 26 years. That's an incredibly long time for a satellite. Terra was a cornerstone of NASA's Earth observing system, wasn't it?
Absolutely. It carried 5 key instruments that gave us a holistic view of our planet. There was MODIS, which mapped global vegetation and land cover. MICER gave us data on airborne particles or aerosols.
Right, and I remember MOPIT, which tracked carbon monoxide pollution.
While Ceres measured the Earth's total energy budget, and ASTER created high-resolution maps of land surface temperature and topography. Together, they revolutionized our understanding of climate change, pollution, and how natural disasters impact the globe. Terra's data will be studied by scientists for decades to come.
From a mission that's ended to one that's making new and, frankly, shocking discoveries, the James Webb Telescope has turned its gaze to an exoplanet called TOI561b.
This is a super-Earth about 50% larger than our planet, orbiting extremely close to its star. Its year is less than half an Earth day long. Because of that, it was thought to be a barren, tidally locked rock with one side perpetually scorched.
Makes sense, a dead world. But that's not what Webb found, is it?
Not at all. Webb's instruments detected signs of a significant volatile-rich atmosphere, and even more surprisingly, the data suggests the planet might be covered in a global magma ocean.
A magma ocean? So this supposedly dead rock is actually an incredibly dynamic volcanic world with an atmosphere? How is that possible so close to its star?
That's the mystery. The leading hypothesis is that intense volcanism is constantly replenishing the atmosphere, which would otherwise be stripped away by the star's radiation. It completely challenges our ideas about where we might find atmospheres and what habitability even means under such extreme conditions.
Finally today, we have a story that is truly out of this world. Let's talk about the space burial company Celestis.
Celestis has been offering memorial space flights for years, launching small capsules with cremated remains or DNA into Earth orbit, or even to the moon.
That's right. And they're about to launch their most ambitious mission yet, the Infinite Flight. They've partnered with an up-and-coming launch company called Stoke Space.
And this flight isn't just going to orbit. Where is it headed?
This one is going into a permanent orbit around the sun. The payload containing messages, DNA, and cremated remains will essentially become a man-made comet traveling through the solar system for, well, infinity.
It's a poetic and profound way to create a final memorial, turning a final journey into an eternal voyage through the cosmos.
And that's a wrap for this episode of Astronomy Daily. From the challenges of space junk to the secrets of the Kuiper Belt and the fiery nature of distant worlds, there's always something new to discover.
We want to thank you all for tuning in. We hope you'll join us again tomorrow as we continue to explore the wonders of the universe. If you can't wait until then, please visit our website at astronomydaily.io and check out our continuously updating newsfeed or connect with us on social media. You'll find us on all the major platforms. Just search for Astro Daily Pod on your favorites. Until then, I'm Anna.
And I'm Avery. Keep looking up.